continuing this perspective on the future of water management. And so we've got a really nice panel here. We'll kind of have similar format as we've done for our other panels. Each of the panelists are going to share a few thoughts. I have a couple prepared questions for them, and then we're going to open it up to the audience to have a discussion. So up first is Amanda Grint from the Papio NRD.
All right. Well, good afternoon, the last session of the conference. So I'm the assistant manager at the Papio NRD, the Natural Resources District, and you're probably real tired if you don't already know about the natural resources districts in Nebraska. You're probably real tired of hearing about it. However, there's 23 natural resource districts in the state of Nebraska, and they were formed by the state legislature in 1972. So this final panel kind of talking towards the future of water planning and specifically urban areas. I just wanted to touch on the structure of the natural resources districts, because I think that in 1972, that was a great thing that the state legislature did for our state. It really set us up for good planning then and now into the future. So it's really, the next slide I have shows the district of just the Papio NRD. So even just within our own district, we have 6 counties, and we have very diverse land use throughout our county. So the northern third of 3 counties in our district are really mostly rural agriculture communities, and then the southern third is a lot of the urban area, and we're the only NRD that has a metro class city. So a third of the state's population is not only within the Papio NRD district, it's within one watershed of that district. So pretty unique, but you can see the differences throughout our state. And this format really gives us the opportunity to have the NRDs, which are run by, they have elected officials, elected board who direct the staff. So it really allows the state to tailor what water issues are important in that district. And I know we had a couple of the other NRDs surrounding, the Lower Platte South and North. I think Lower Loop was here for the conference too. And even though we're some of the NRD districts that are pretty close together, we have very different issues that we deal with. So I think this was great planning and will continue to be good planning for the state of Nebraska in the future. For our district specifically, we have, as I mentioned, you can see the Omaha Metro is in that darker red. So that's quite a bit of our district is the urban area. And then this kind of zeroes in a little more to those southern 3 counties. The outline in red is the Papillion Creek watershed. And then the kind of the yellowy shaded area is the Omaha Metro urban area. So you can see a third of the state resides in just that watershed. So for the Papio NRD, we spend quite a bit of our time working on projects, water quality, water quantity, and other issues within that watershed. That's where a lot of our constituents and a lot of our dollars come from. And I think I'll just throw out, so the operating budget of the Papio NRD is $90 million this year. And that's a lot of money, but it's also, we have a lot of folks that we need to provide projects for. I think some of the most, I'm going to go back. The most successful planning that we've done in the past that's really going to lead us on into the future is back in 2001, we created the Papillion Creek Watershed Partnership, and I think you heard Jim Tyler mention that yesterday. Lori Laster from our office gave a really great talk on that yesterday as well, a little more detail. But that formed in 2001, and it formed for a couple of reasons. We had to address storm MPDES permit. We had to address water quality and water quantity in the watershed. And we thought it would be better to do that together. So there's 11 communities. So it's not just the city of Omaha and the Papio NRD. It's Gretna, Ralston, Boys Town, La Vista, Bellevue, I'll probably forget some, but there's 11, the counties, Sarpy County, 11 of those communities, we all worked together, and we did that in order to form policies and do projects across the board that were equivalent, so that, say, the city of Gretna didn't have different stormwater requirements than the city of Omaha. It makes it easier for developers to move around in the watershed. It makes it easier for all of us because we're not pushing people to other areas that have maybe more lax kind of regulations on stormwater. So that was a really unique group, and I'm really proud of that group. I'm proud to be a part of it because it's 22 years old, and that's a long time for 11 communities to work together and to continue to have common policies, common goals, and it's been very, very successful for us. It also gave us the framework to set up the Southern Sarpy Watershed Partnership, which, so just south of the Papillion Creek Partnership, a different watershed, is Southern Sarpy County, and that's really a rapidly developing watershed, and it drains to the Platte River. So the Papio drains to Missouri. This drains directly to the Platte. And so we were able to take a lot of the Papillion Creek Partnership framework, but the South Sarpy has different components that we needed to address, but it gave us that framework to set it up. So you've also heard through this conference, Jeff Thompson with the Southern Sarpy Sewer Agency talked, I believe. And so when they developed that sewer agency and started building sewers to open up development there, we recognized really quickly that, oh, well, there's no stormwater policies for that watershed, and there's no water quality. There wasn't anything. So we were able to get something established there and really, again, work with all the communities. You can see the partners on the bottom. That's Bellevue, Gretna, Springfield, Papillion. So this partnership is a lot the same as the Papillion Creek, minus Omaha, add Springfield. But it was really a great framework to start to address water quantity and water quality issues as things develop. So I think those two partnerships have really set good water policy and good water projects in the urban area, and I think they're going to continue to do that for the future. I think a couple of the major, that's all I had for slides, but I think a couple of the major concerns that the Papio is going to face as we move forward in the future. We've done a lot of planning, and there's so much planning has been done in the Omaha area going way back beyond 1960s and beyond from the Corps of Engineers. So we've had a lot of planning, and we look forward to doing more of that. It's just, I believe that partnerships are a very important part of that, not only with our local communities, but also with federal agencies. And I think the maintenance of our existing flood control infrastructure is going to be very, very important moving into the future, because much of it was built, I don't know, I'd say 70s, early 80s, and it's getting to be where we really have a lot of maintenance and upgrade. And also with climate changing and things, there's just a lot of upgrades that need to happen. And that partnering is important. It's important to mention maintenance, all because, that being said, I feel like water projects in the urban area are very expensive. And it's just something we have to address and work on partnerships to address, because you've got a lot of expensive land, and you've got a lot of existing infrastructure, utilities, buildings. A lot of things have to happen if you need to make changes. So I think looking towards the future, we need to really work on planning for those expenses as we move forward.
All right, thank you for that great introduction. Next up, we're going to hear from Tim Pendrell. He's from Senator McDonald's office to share a little bit. We kind of go from the infrastructure planning side to, well, I guess it's still infrastructure, but talking more maybe some recreation and some other aspects that are upcoming in our water management area.
Yeah, thank you. I'm filling in for Senator McDonald. The main thing kind of wanted me to talk about was the lake along the Platte from a couple of years ago and give an update. Well, there really isn't one. you heard from Lincoln's Water 2.0 project. That comes first, and it's kind of how the hydrology studies and what happens there would then lead into further studies. But to give you kind of a background of how that all got started, I started working for Senator McDonald in 2019. We had just had some flooding issues, and wanted to re-explore what's come up essentially every 20 years since 1895, which was water storage around the Platte River. Having followed this for at least the last 20, 30 years, the last two times this came up with former Mayor Daub, Senator Pam Brown, they were pursuing studies and they got stopped really quick because of the fear of what happened in the past, where it was talking about putting a dam along the Platte River and having communities relocate, which isn't what I mean, it's just not really feasible. So we wanted to kind of get past that to where there could be a study and we could look at it, because we want to look at things like parallel storage, steps, locks, pumped hydro, and other options that could exist in the lower Platte. But every time for the last at least 40 years, there's been any communication, the first thing that would happen would be like, well, here we go again. We're going to move. Originally it was Wahoo, but more recently it's gone to Ashland. And so the legislation that did the study also included some amenities up around Niobrara State Park and around Lake McConaughey, was just to look at other options that would not include damming the Platte River. So we were really trying to push for parallel storage and had a short period of time to do it, and came back with a sand pit in a city. So after Lincoln studies in, because if you're crossing I-80 as you cross the Platte River, you'll see that there's a little sand pit lake there that's Dan Bundy's, and he's done some wetland preservation on the north of Highway 6. Pretty much everything south of there is Lincoln's wells. So it's currently their primary water source coming off the Platte there. So their water issue and whether or not they're going to be going into the Missouri with a pipeline, or whether or not there's some other options, that comes first, and then there'd be economic feasibilities looking at some other areas in the lower Platte. But I do recommend, if you go to the library and get all the old articles going back to 1890s, it's exhilarating. The articles are the same. The opposition's the same. It coming back up every couple of years, and it always comes about 10 years after floods. So it's pretty consistent there. But they could be written tomorrow. Like they're pretty much the same, kind of the same. Originally it was going to be a canal, get some support, then it becomes a real estate development, and then it dies, and just repeat that every 15 to 20 years, which is why we wanted to kind of avoid that and get to actually looking at the water system. But the last kind of presentation kind of fits in nicely with some legislation we're working on now. So last year, Senator McDonald introduced LB 656, which was for the small watersheds, to put money into the small watershed control fund. I think it was Papio NRD met with Tom Riley and brought up the issue that we were already looking at, and he discovered a small watershed fund that had $0 in it, so the cash account already existed. Overall, in the state of Nebraska right now, there's about $5 billion in water projects that have been approved that the federal government would pay 90% of. Some of the more rural NRDs, they may have budgets under $1 million. So the idea that they would be able to bond and kind of come up with even a 10% match on some of these projects isn't exactly feasible over the next 30 years. Some of this is maintenance and replacing older flood control operations. Some of it would be new. But overall, last year we had 5.5 million acres crossing 43 of the 49 legislative districts in the state of Nebraska. to fund them all last year. There's been some more approved. It would have been, was it like $404 million over the next 30 years? But the state did about $575 million for the Perkins Canal. And I'm trying to get which one would actually be more water, because we've talked about how Nebraska's #1 export really is just our water resources, and maintaining quality and being able to maintain that water is going to be increasingly important as we go forward. And the other kind of bill we tried last year, until bill drafters told me I had drafted it extremely unconstitutionally, was for permeable surfaces. What the goal was, and how we tried to write it, was that if you were to convert parking lot into permeable surface, that it would be taxed separately, and it would only be about 25% of its value. And we were trying to get to that cost to where it would be cheaper and more efficient to do permeable surfaces on those larger parking lots. Only ag's allowed to have a separate, distinct class of property. So we couldn't do that. So the idea of doing it through kind of the property tax levy was nice, because we didn't have to come up with another system. We could just figure out what that rate would be. But we have to figure out a different way to kind of finance that. With the goal being is trying to figure out some sort of value capture to where if people do put in permeable surfaces, if they do zero-scaping, anything that would keep water out of the overall system and maintain it, that there would be a financial advantage to that, or at least there wouldn't be a disadvantage for doing that, to try to lower some of these larger scale costs over time by decentralizing it. And then we had a bunch of bills just about doing studies on irrigation, smart irrigation, and using some of these new technologies to see if we can lower the amount of, it's like 95% of Nebraska's waters for center point irrigation. If you do a 10% reduction in that, that's substantial water savings. So we're also kind of trying to figure out issues to do with that. Last session was very, very odd. So we'll see what happens with that. All those bills from last year that didn't pass or didn't have action, they carry over to this year. So they can be amended. They've already had their hearing, and there's some opportunities to do things with those kind of carryover legislation. I think that's about it for the update. Session starts in January, so November and December I'll be writing up new bills. So if anybody has any water bills, we can easily introduce them and get a hearing for them. Probably not a great year to get it passed, just because it's a short 60-day session, but you can get the hearing and we can get a lot of information from those hearings usually.
Thank you. Good overview. And to round out the panel, Mike Beringer from EPA Region 7 wasn't able to join us at the last minute, but our director of the Nebraska Water Sciences Laboratory, Dan Snow, is with us here, and he's going to talk. This is what Mike, we'd asked him to talk a little bit about PFAS, since some of you may know all about it, but others it might be new. This is kind of an emerging, will be one of the larger upgrades to the Clean Water Act in a while. So wanted to introduce that topic to you. And so Dan does quite a bit of work in that space and stepped up to fill in.
Thanks, Crystal. So a heavy chemistry talk for the last one of today, huh? I'll try to keep it short. There we go. So, the conference has been about water. I've worked in water pretty much all my career, and one of the things I've learned is that the water we're using now has been used for other purposes. Right? We're always using somebody else's water for whatever beneficial use that we might have. We're also using more chemicals now, and what people have come to know is emerging contaminants are just new, and I put new in quotes because they're not really new, they're just things that we now know are present. Are chemicals, contaminants that include things like pharmaceuticals, steroids, personal care products, plasticizers, surfactants, flame retardants, and all the degradation products that come about because of these chemicals in the environment. They're not really new, but now we can measure them, and we're trying to understand what the consequences are for their occurrence and our exposure, human exposure and exposure to environmental endpoints, and see what we can do to control risks to these water uses. So some people call these emerging contaminants, and I really like this Environmental Science and Technology feature article analyzing ignored environmental contaminants. That's something that I've pretty much taken on as my field of research. The latest emerging contaminant are these PFAS, or perfluoroalkyl and polyfluoroalkyl substances. It took me a while to figure out how to pronounce that, so I just say PFAS for short. My first exposure to PFAS was a colleague in Delaware called me if we could test for Gen X back in 2013 or 2014. And the reason that he wanted to know if we could test for it at the Water Sciences Lab is that the Cape Fear River in Wilmington, Delaware, had been regularly contaminated with this PFAS compound called Gen X. And they really didn't think very much about it because it wasn't regulated at the time. Low concentrations of these per and polyfluoroalkyl substances that we now call forever chemicals were detected in the Cape Fear River upstream from a public water supply. And the public water system was obviously contaminated with this and other PFAS compounds. So they were a little bit alarmed. And this is kind of the beginning of the PFAS, I guess I would say, fad. It's not really a fad, but it's kind of our new emerging contaminant. Much of the work that's been done since then have found traces of these per and polyfluoroalkyl substances throughout the world in ground and surface water. So it's something that we now know is present, and we're trying to understand through measurement, careful measurement, where they occur and what the consequences are. So why do we have these in the environment? Well, they're associated with the discovery of Teflon, working with gases related to refrigerants at DuPont. Roy Plunkett accidentally discovers polymerization of tetrafluoroethene into PTFE, that's a Teflon, in 1938. So that was registered and became widely used as a coating on cookware, stain repellent for fabrics, inert construction material for harsh manufacturing and industrial and laboratory environments. We use lots and lots of Teflon in the laboratory because it's so inert. Well, you'd think if it's inert, it's not going to degrade, right? It's not going to react. It's not going to occur in the environment. Well, that's not a good assumption. Just the chemical structure of Teflon. So this is a great life cycle, or kind of the emergence timeline for PFAS compounds. That discovery of Teflon in the 1930s, immediately followed by lots of manufacturing in the 1950s and 60s. And I remember my grandparents were excited to purchase Teflon-coated cookware because it was easy to clean, right? Stuff would not stick to it. It was actually in the 1970s that they detected PFAS in human blood, but we kind of didn't really do very much work on that until the early 2000s. That's about 20 years ago, when there was a study in Minnesota, University of Minnesota, where they systematically found PFAS, PFOS, and PFAS in serum samples from all over the United States. And that's when they began to talk about phasing out this PFOS and PFOA. 3M was the company that was manufacturing it. And then through that time, the last 20 years or so, we've come up with environmental methods for detecting these throughout the environment, including human tissue. And now we're deciding that we probably should stop using them for some purposes. This just gives you an idea of the complexity of the per and polyfluoroalkyl substances. There's a whole bunch of different ones, and I'm not going to go through and name all of them, but The main idea here is to show that they all contain fluorine. Some contain carboxylic acids and carboxylates. Some have sulfonic acids as the functional group, and sulfonamides. So these are just kind of your main classes. And then one thing that I've learned is there are literally thousands of different PFAS, thousands and thousands of different kinds of PFAS. So how do you develop methods for detecting these? Well, it's really not possible to measure all of them. One of the good things that we now know is that there's only a few groups that are really likely to occur in high concentrations in the environment. That's the carboxylic acids and the sulfonic acids and the phosphonic acid compounds. Sources in the environment, treated municipal wastewater and land-applied sewage sludges or biosolids are very important sources in the environment, not just in agricultural states like Nebraska, but everywhere that we apply biosolids have the potential to release PFAS. And then there's some pesticides that actually are PFAS precursors, like sulfuramide is an insecticide. And then AFFF, these film-forming foams, aqueous film-forming foams that we have used traditionally at airports for military operations, for firefighting, is another source for PFAS in the environment. So why are we concerned? And it's really only been the last 10 years or so. We knew back in the 70s that these were occurring in human tissue, but it wasn't really until the last 10 to 15 years that we're starting to understand that there might be some consequences for exposure for humans. They may be linked to thyroid issues, increased cholesterol, certain forms of cancer, liver damage, inflammatory bowel disease, and then it is also related to birth issues, increased time to pregnancy, and pregnancy-induced hypertension. So this is a journal article that kind of goes through the list of potential human health effects. USGS just this summer published a survey from across the U.S. They sampled pretty extensively from across the U.S., both public water systems and domestic wells, 700 private and public water supplies throughout the U.S., and they detected PFAS in about half of those samples. So that kind of gives us an idea of the incidence for potential exposure. Now, most of the concentrations were very low, so just trace levels, but we're talking about part per trillion and part per quadrillion levels. Benchmarks and U.S. proposed PFAS regulations were exceeded in some samples from private and public water supply tap water. So just to summarize, PFAS are a new group, and it's not really a new group, it's just a group that we have learned how to make measurements on and now find in the environment. They're highly persistent because they're fluorinated. They occur in the environment and they're likely to be with us for a very long time. Characterized by highly fluorinated functional groups, occur in everyday products that we use, and also in municipal wastewater, biosolids, firefighting foams, although those are being phased out, in many industrial sources that are most important to the environment. I think that's it.
Does anybody have a burning question about one of their presentations or a specific follow-up before I ask kind of more general question to the panel? Maybe one just from Dan's that made me think of, do you know the timeline for when these will become a regulated substance? Because they're kind of in a preliminary phase right now.
Yeah, the MCL for PFOS and PFOA, yeah, has been proposed, but not enacted. So I don't know what the timeline is to sign it into law, but I know that they have proposed these maximum contaminant levels. So the issue that comes about is if they make this a law, then public water systems have to regularly test and demonstrate that they're not occurring above those MCLs. And I think that's quite a huge undertaking.
All right, well, I'll jump in with one of my questions. And so it's kind of a real general one since each of you spoke on very different topics. But how can the professionals and students in this room, what are some of the ways that they can best prepare for, the issues each of you talked about? How can they get involved and how can they prepare?
You want me to go first here? Well, I think for the future of urban water management, as far as structural type, existing infrastructure, levees and dams and the channels and the things that we have, I think it's important to know that with the change in climate, there's always it's not like these levees are going to get built and then they're done. I think that there's always going to be upgrades and work to do on the existing infrastructure, as well as looking at new infrastructure that could help your community. So I think that there's really just no shortage of work in that sense. And then I also would say, I think looking towards the future, I think water quality, Dr. Snow talked about it. We've heard a lot about it this last couple of days, but I think water quality is going to become an even larger issue. Groundwater quality and just in general water quality. I know just at the Papio, just as a note, we and many of the NRDs do water quality management plans for their whole district through the Nebraska Department of Environment and Energy. And part of that is to list all the practices to remove or to improve water quality to the acceptable level in your district. And it's kind of an exercise, because like you wouldn't be able to implement really all of those things. I mean, that would be a miracle if you could do that. But it is an exercise to go through and lay that out to see what you would need. And the number is staggering. It was, well over, but 1.9 billion, I think, in our Papio, just the Papio NRD district, of practices that you would have to put in to bring water quality, E. coli levels, to what the standards were. And so as I think about that, I think, wow, that's a big thing that's going to happen in the future.
Yeah, so I think the question had to do with like career pathway, or
Just what are ways that they can prepare, both
Yeah.
students and existing water professionals? Just
Okay.
your thoughts on
Yeah,
it's a very wide open question.
I know,
there.
yeah. So I'm going to take this from the student side of things, and what I like to see for students is that they get a really strong background in science, engineering, and then learn how to communicate that knowledge to the public. So often scientists come across as not great communicators, and we need science in understanding how to solve complex problems, and we need to learn how to communicate that science. So those are two really important qualities if you're going to work in any water resources issue, is to learn and be able to explain science in very simple terms.
I think for the legislature, it's pretty easy. You could just kind of show up. It's every only state in the country where every bill gets a hearing, and even if you miss the first 10 days of actually being able to introduce a bill, legislative resolutions can be all the way through like the 80th day in a long session, 60 day and a 70 and a shorter one, 50. And that can get a hearing, which you can get the press, you can get some attention for it, but you can also inform the committee. And usually we do that to try to get legislation for the following year. But for me, I grew up in Nebraska and I moved to, I got my master's from NYU in urban planning and started in 2009. So pretty much all the classes were about environmental sustainability and demonstration projects that were really low scale. Being over here, he has a assisted dwelling unit that's carbon neutral that he's building with students behind UNO's baseball stadium. But when I was at NYU, one of my first projects, we went up and met with Dr. Mankiewicz, who was kind of New York's mad scientist, borderline illegal environmental remediation projects. And up on the Bronx River, there was a recycling plant, the Hugo New recycling plant, and went up and visited it. And it's right on the Bronx River, and you would see, they had a bulldozer moving machines in, and big purple plumes were coming out of it. And he did groundwater study that showed all the contaminants and everything off that was going away from the river, getting in the groundwater, then getting into the river. So he built a green wall, little, just basically a little swamp. And he had moss walls, and he had a pump, and they'd be pumping the water, constantly filtering it through moss. Every plant that he had planted was for a specific chemical. And like if you look at New York City's flag, it has beaver pelts on it because that was the first industry. And there hadn't been a beaver in New York City in about 250 years. That project cost them $80,000. It ended up going over budget because they wanted a solar pump, even though he just would have plugged it in because it didn't take any energy. So it had its solar pump and it was working. 3 months later, the first beavers in the Bronx River in 250 years. And that it was a really cheap intervention. He did it all through grants. And now it started to pick up. The Billion Oyster Project, like a lot of people who are talking about bringing back the oyster reefs, whereas New York Harbor was at one time the largest oyster reef on the planet. That started that conversation. Now they do whale watching on the Hudson River. Water is the cleanest it's been since the 1700s. Just in the last 6-7 years, off these projects that weren't really all that expensive and were volunteer done. So like here in Nebraska, I think more of those kind of cheaper demonstration sites where you can kind of show and study smaller scales, like talking about the permeable surfaces. Anything that we can show that examples that could cause an example, change policy, it makes it a lot easier for people to understand how it works when they can see it. And especially when you can match and you can actually show the costs compared to, Lincoln's going to build $1 billion pipe to the Missouri River. That might be the best option, but it's a pipe. Pipes go fast. Pipes, if they don't have the capacity and capacity increases. There's great video of a river running down Leavenworth Street multiple times every time there's a flash flood, which I don't remember 10 years ago. Now it's like twice in the last couple of years. And living down there, watching cars just kind of float by just because it rained for an hour and a half. It's hard to keep pipes at scale when if we could reduce any of the water from getting into the system, even small sections can have big impacts, and huge impact on water quality just by filtering it. Plants can filter a lot of water and clean a lot of water before it just starts flowing downriver.
So to build on that a little, my second question was based on how do these extreme weather events kind of impact each of the spaces you've talked about, water quantity and quality. We've heard a lot about it already, but other thoughts on how our region can better prepare both in our physical infrastructure and in the people in this room to deal with. And I heard the 3+1 from Sybil, so maybe even expanding beyond climate to biodiversity loss and help me remember. Air pollution and land degradation. So we'll make it even bigger question. So you can take it whatever direction you would like.
Well, the changing climate really has a super direct impact and a big impact on existing flood control infrastructure. I mean, if you think of it like the levees, you build whoever built that, whether that be the Corps or at whatever time, they are built to a certain level of protection, and they're to protect the people that live behind there. And with every storm event, there's the chance for something beyond that to happen. And over time, it's a very, changing, the climate's changing and the storm events get, more intense or whatever. And that really has a major impact on just the existing infrastructure, but also has a really big impact on our design and for future designs. And, there's just that line you have to, if you could build it as safe and as perfect and as high and strong as you want it, I mean, there's not enough money for that. So there's some level of working in climate change into your projects, and that's just a risk factor that you have to work into your project. So I think that's something we definitely deal with all the time on our existing infrastructure, and then on anything that we're proposing, we're always thinking of that.
Yeah, I think planning is critical, planning for the future and for the present. My degrees are in geology, and we learned about flooding, how you can zone areas for no construction because it's prone to flooding, right? So that's the job of the planners, is to recognize that that's going to happen. If we're going to be moving into more serious droughts, we need to plan for alternate water supplies so we can manage demand during times of drought. So I think it really just takes acknowledging that the system, a lot of these factors are beyond our control, and to plan for the things that we have to do when times get tough.
Yeah, about the same. It's for me, it's just slow water down, use natural systems as much as possible to avoid the big cost. And then, like when I was mentioning the permeable surfaces, as far as policy goes, we're trying to figure out ways to monetize it to get some value capture, so that anybody who does kind of put in systems themselves, it'll be a lot easier if we could figure out a way to finance it without mandating it, and finding options for if somebody is able to, if a farm's able to reduce its water, how they could benefit through yields, but also through like ground quality, using less water, storing less water. It's the hard part because largely the Constitution, but there's always a way around it. So it's just, we can't do more tax credits. So it's like, if there are ways to do it and figuring out ways to kind of finance it, I think it would happen relatively quick. There's not huge punishment, and depending on which city, some cities will have more impact fees. Lincoln's always had really high impact fees. They made it more difficult for sanitary improvement districts than Omaha, but they still have a water shortage. So it's it's kind of figuring out how that overlaps and how to make it tolerable so that it's not a huge cost burden, but over time it could lead to kind of, if we're looking at 30, 40 years, it might not take as much if you're doing it over a long period of time to kind of catch up. And that's kind of policy-wise, it's just trying to figure out ways to do everything a little bit cheaper and make it beneficial so that it's financially feasible.
And I have one more prepared question. So you guys be thinking of what your questions are for the panel, because we'll ask for those next. The last one I had for the panel is, we've talked a lot about the challenges that we see and just a little bit on the opportunities, but if you could pick one or two of the top opportunities you see to make our urban water future more robust, more resilient, what would those be?
I think partnering and collaborating, I think, would have to be the biggest opportunity. I mean, I even saw that today on our tour. We kind of got on the topic of urban agriculture, which we had some staff members at one of our tour stops, that then there were I saw some cards changing hands. And, it's I think that kind of stuff, that's really, I think it's going to take that, I guess, is what I want to say, to make that more robust. We have a lot of people doing a lot of good things. And I think combined, it just makes it, financially better. And just people have different resources. It makes it just more robust when you get different inputs from a lot of different folks.
Yeah, I agree with that. And one thing I would add is, look to the past. And if we don't have to reinvent how to deal with disaster by observing how other cities in other countries have dealt with them, let's borrow ideas from outside the U.S. We had a conversation at Bing's house this afternoon about how ventilation is designed in India. And I didn't even think about that, but it's like, we've had disasters throughout all of human existence. We can borrow and use ideas from history and from other places that might make our lives easier now.
Yeah, there's actually like a lot of really cool old technologies. There's a village in India that's basically in the desert, but it has a small creek running through it, and they put steps and locks in just to raise it, and it's been an oasis for over 1,000 years, and it shouldn't even exist. I think like the hard part's the urban environment, because it's owned, so you're dealing with landowners, but through I'm not sure which bill, but I think it's either the Infrastructure Bill or the Inflation Act. Both were misnamed. It's the Inflation Act. That was the more misnamed bill. The money and the resources they put in for like carbon capture and green roofs, the amount of water that could potentially be just slowed, because a lot of it with flash floods, it's just you slow it. You can do a lot, but there's also money for it. So you can get basically carbon credits. So I mean, if you just look at a satellite view of any city in any urban area, you're going to see a lot of gray, and that means the water is going to be moving fast. There's nothing to store it, and there's nothing to absorb it. So I think anything that we can do as far as like within our parks, within kind of around the levees, any area that the water is moving fast, that we can slow it down with and retain it a little bit. The permeable surfaces would help a lot. And then just at some point there's going to be large scale infrastructure, but even that takes a long time. So it's, I think the more we can slow it down, use those technologies, urban farming, green walls, the temperature impact of like green roofs and green walls and air conditioning and energy savings and insulation is extremely high. And they're happening. It's just, it's expensive to talk Walmart or a Kmart into putting a garden on top of their roof so that they could save a little bit in energy. But the amount of water and rainwater that could be stored and slowed down is fairly dramatic if you had it large scale.
Excellent. So who's got the first question for our panel? I can come to you, or you're welcome to come up to the microphone. I know it's mid-afternoon after a couple days, but. Mm-hmm.
Hi, my name is Carrie Stanek. I was just wondering, you said that back to the PFAS, they're proposed but not inactive as far as regulatory or regulating those. Is there any discussions on treatment plans, how to take those out of wastewater, drinking water, how to treat the water?
I think the question is there discussion of regulating it in wastewater? Was that correct? Oh, how to treat it
in the drinking water.
Yes. Well, it depends on the scale of treatment, obviously. For personal water, domestic water sources, you can treat it using a activated carbon filter. Public water system, I think, would be more challenging, but there are treatment technologies that might work for PFAS should we decide to regulate them in drinking water, public water systems.
Other questions? Mhm.
Probably about 10 or 15 years ago, we weren't talking about PFAS. We were talking a lot about endocrine disruptors and the impact on hormones with everything that's getting into water, and that's got to be still out there. And why aren't we talking about that anymore?
Yeah, we did some work in steroid hormones. It turns out that they do occur in wastewater, but they're pretty readily degraded in surface water. So I think they're not as big a concern to public water systems. There might be a few places where a private supply would be impacted, but they're not as prevalent, I guess, and likely to influence public water systems as we might have thought.
I was maybe more concerned, maybe not as much the public water system, but more the natural environment. And weren't there a lot of issues with the fish? And,
yeah,
and
so,
was there any concern
yeah.
about that degrading the populations?
They do, where they do occur in wastewater, effluent, and other wastewater introduced into surface water. They do influence feminization in fish populations. We know that happens, and it does affect the predominance of certain species of fish in wastewater effluent. We have not chosen to treat that in effluent, but it does have a biological effect and a consequence.
Other questions? Mhm. You can do it. Yes. Mhm.
Thank you. I'm Bing Chen with Electrical and Computer Engineering at UNL. My question is, how serious do you think the microplastics contamination that's being found in a lot of drinking water systems, how severe do you think that is? And is this something that we should be concerned about?
Well, we use a lot of plastics in our plumbing distribution systems. In fact, I think plastic is our go-to pipe now. We use plastic in almost everything to convey water, treated and wastewater. And because we're using so much plastic, it's likely that we're introducing particles of plastic in our water supplies, water systems, and we know it occurs in wastewater. We include plastic particles in many of our personal care products. If you look at microbeads, those are just microplastics that we introduce into products. They're everywhere, kind of like PFAS. These are both emerging contaminants. They're with us now. We know they're present. We don't necessarily understand all of the consequences for having them in the environment, nor do we understand the consequences of long-term exposure and consumption. So that's something I think we're still learning.
Any other questions? Well, we don't mind quitting a little early, but I also don't want to cut off if someone has a question. Otherwise, not seeing any, let's thank our panel for a good discussion. All right. Well, with that, thank you so much for a wonderful 2 days. We'll look forward to, we have a spring seminar series, which we broadcast live, or you can join us in Lincoln. And we're always open for ideas for what topics you would like to see in future years for this conference, which we hold annually. And we have a water tour, which we also hold annually. So please do fill out the survey that's on the last page of your booklet. Give us feedback on this event and future events, and we'll look forward to seeing you there. Thank you.